You're listening to the Knowledge Archives podcast. Welcome to the Knowledge Archives podcast. We're a group of students on a mission to learn from as many different disciplines of knowledge as possible. I'm your host, Madhav Malhotra, and today I'm glad to be joined by Dr. Rino Lovreglio, a senior lecturer in digital construction and fire engineering at Massey University in New Zealand. His work focuses on evacuation behaviour in situations like natural disasters, especially when it comes to how this behaviour can be simulated with tools like virtual reality or crowd modelling. I'm very excited to learn more about this crucial discipline and how it can be applied in our modern societies. I really appreciate you taking the time to explain a little bit about what you do, all of the complicated details involved in a lot of very important areas actually. But before we dive into that, I'd just love to learn a little bit about yourself, your story, how you got started working in this area, etc.
Kia ora, it's Rino Lovreglio from Massey University, New Zealand, and I'm a senior lecturer here in New Zealand, where I teach digital construction. And my main focus of research is investigating how people behave during disasters. And I've been doing it for the last 8 years, I guess, or even more. And I've been using a lot of new technology to understand how people behave during, especially fire evacuation. And I done it using different kind of approach, but the one that everyone is keeping asking me about, how we can use augmented reality or virtual reality to investigate human behavior. And something that I started also in my path is use this technology also to train people, give them the best preparation in case they need to handle an emergency.
Mm-hmm. And when it comes to this area, I know that you have the intersection of a lot of different kind of tools that you need to use here. And when you consider doing things like studying behavior, often people think of sociologists and psychologists, but then you also have such a huge technical background in the tools you use and also thinking about the different ways that you can simulate behavior even, which kind of requires a lot more skill in the methodologies and the statistical approaches that you're using. When it comes to putting together all of this, how did you come to acquire all of these different skills?
I started with an undergrad in civil engineering and then a master in still in civil engineering. And so I have a really strong background in mathematics and applied mathematics. And since then, I was a really big fan of statistics. I was really passionate about statistics. And we managed to have a different statistical application, different papers in different courses on my undergrad and postgrad. And then towards the end of my master, I discovered the field of fire evacuation and fire safety engineering. And one of the branch of fire safety engineering is simulating human behavior. And that's why then I got so passionate, because it was the perfect space for me to apply a lot of things that I liked, like programming. I really enjoy during my master doing a lot of programming, just learning by YouTube. And that was like the right project for me for my master, the research project, to combine all these skills and managing to apply statistics, to apply programming, and to apply something that it was like really curious for me, try to understand how people make choice and understand how we can simulate those choice in our simulation to do prediction in terms of how long it will take to evacuate a building or an infrastructure. So that's in short what was my path. I got really lucky that I discovered fire safety engineering towards the end of the master, because then I fall in love with many of those aspects.
Mm-hmm. This area, it's something that everyone kind of relies on. Basically, any building you enter, there's gonna have to be some kind of, say, fire safety plan, some kind of other evacuation plan, but it's something that no one really ever thinks about. So first of all, when it comes to creating evacuation plans and thinking about the behavior of how people might perform in an evacuation situation, What are some of the factors that we like to consider, and what is important in terms of the issues that might be brought about in terms of not adequately planning a proper protocol?
Yeah, no, it's really important that we keep in mind what we know already about human behavior, because sometimes when we do design or even evacuation plans of existing building, we make assumption of what we wish that it will happen in case of evacuation, like that everyone start evacuating straight away or choose the closest exit. But we know from many studies that people are much more social beings, so they tend to follow each other. You can't expect that people will start evacuating straight away, because we keep gathering information. We are curious to understand what is going on and try to figure it out what's the best strategy to take in place. And all these aspects in the past weren't really known, but I can say in the last 40 years we have been discovering quite many things that can be actually be applied when we design building, expecting that many people will use, for instance, the main entrance of a building because they are really familiar with this exit. And so it's more likely they are going to end up using this, although it's not the closest exit. And a lot of things like this, like we tend to follow other people because we build trust on what the other might do, and we probably think that other knows what they are doing, and we start following them. Something that instead we don't in the research we don't use quite a lot is the word panic, because the word panic is kind of assuming that everyone, the people that are panicking, are not following a rational decision. But we have seen many times that people actually making rational decision. And if it happens that they do something that doesn't look like an optimal decision, it's just because they didn't have enough information to take the right decision. And from an external point of view, this might seem like they were panicking, so they didn't know what to do. But in reality, is that most of the time bad things happen because we don't provide people with the right information, or we don't have a system or building in place that are capable to address a specific emergency.
Hmm. And then building on top of that, when it comes to studying this behavior, why is it important to create simulated models or other tools that can help us study this outside of the real world context?
It's important because in many countries we have the so-called performance-based design approach. And to make the design of a building, we are not any longer required for a fire safety perspective to follow strict rules, to put defined number of exit, and the distance between the exits should be in a certain within certain threshold and stuff like that. With the performance-based design, we leave the designer free to do whatever they want in terms of design, with the condition that they manage to prove that if there is an emergency, there will be enough time for people to get out. And to do that, you need to simulate the threat, that is the fire, and the evacuation of people. And then you manage to compare the time that is available to evacuate with the fire simulation, and at the time required to evacuate using the evacuation simulation. And when you compare the two numbers, you can make an assessment if the building is safe. And basically you can end up using whatever you want in terms of design, in terms of where to locate exit or many exit, unless with the condition that you prove that the environment will be safe in case of fire.
Hmm. And then when it comes to actually using these tools, I know looking at your research, you use a bunch of tools, different tools in actually conducting experiments. And from the nature of what you just said there, it might seem like you might also make these tools available for, say, commercial applications outside of academia. Could you quickly describe some of the different tools that you use, and specifically in a real life context? How are you integrating them into your research studies? What does it entail in terms of how participants might interact with them, etc.?
Yeah, there is a lot of tools that have been developed for fire safety engineering. And personally, I've started with the open tools like FDS plus EVAC. and it's a tool developed in US at the National Institute of Standard Technology, the FDS part, the Fire Dynamic Simulator. Instead, the evacuation part was developed in Finland by Timo Koroner, and it was one of the perfect tools for me to start learning to simulate both fire and evacuation and see the results. But out there, there is quite a lot that has been developed by many companies and a lot of tools. And what we try to do in terms of research is to provide data that can be plugged in as an input of those models. One of the main data that you require to simulate an evacuation is the pre-evacuation time. That is the time required from the beginning of the alarm of the hazard until the time that someone is starting moving towards the safe place. And this time is now input in those models as a pre-evacuation distribution. So what we do in our research is try to investigate many scenarios and develop those distributions that can be used by designer inside those models. At the same time, we provide more knowledge to enhance the capability of those models because we are well aware that there are a lot of limitations of an existing evacuation model. And what we do is try to generate a new knowledge to enhance the modeling solution adopted by those models. And it's a really long process because it takes years to do those research and it takes years to implement it. So what we are discovering now probably are going to be used, implemented in the next 5-10 years.
Yes, and as you're more aware of, there is a lot of background work and effort going into that over time. But from the public point of view, it's like when we see technologies like virtual reality or AI being used in more and more applications in the past decade or so, there seems to have been a really large increase in the usage of these kinds of tools and the results that we can see out of them, the practical applications that really make a difference when taking the theory and applying it to a real life situation. So when it comes to that, these kinds of new technologies, what have they enabled in your research that wouldn't have been possible, say, 10 or 15 years ago?
There is a lot of things that we learned we didn't have possibility to investigate. Like if you think 10 years ago, virtual reality was something that it was super expensive and just available in only few labs around the world. And now in the only 3-4 years, the last 3-4 years, we had the booming of this technology, and this allowed us to have this technology available for many PhD students, for many young people that are just starting their research and try to test a different kind of scenario and try to really expand and investigate the capability of this technology. And now we are living the same process with augmented reality. Most of the advanced augmented reality headsets are still super expensive, but they are becoming cheap enough to be available for many labs. But we expecting that this is gonna become more available for anyone else that wants to use like augmented reality and use holograms to make study and train people in case of for emergency situation. And who knows what is going to be out there, because there are still a lot of technology that we can use in our domain that are still not accessible for us. But I'm pretty sure that in 10 years there will be a lot of more things that we could apply, and this allows us to dig deeper and try to understand better how people behavior, because we can expose them to many different immersive scenario and try to see what will be their behavior in those circumstances.
Mm-hmm. And when getting towards the practical side of these things, this kind of brings me to my last areas of questions, which are kind of around what are the ways that this technology is still limited in that it can't, say, encapsulate key factors in the way people behave in real evacuations versus what we simulate? And is there a strong link between any gaps that we see here and the utility of this technology in an applied context?
There is a bit of discussion going on in terms of validating the results that we can get with those new technology. And there are already some few studies that have been published, especially in Sweden, by some colleague of mine at Lund University, in which they've been trying to focus and try to discover and highlight what we can trust and what we can trust in terms of data extracted from virtual reality experiments. So virtual reality validation for human behavior investigation in disaster is still a really hot topic, and I can tell that there are few people around the world try to do different study and try to discover how much we can rely on those data.
Mm-hmm. And as we start to see these technologies kind of overcome these limitations, I know you were talking about the importance this has for more people being able to have access to them and then being able to test and ask more questions with them. So as you continue to see this field progressing, my last question for you is just when it comes to the biggest gaps in knowledge in this area, what do you think are some of the most understudied areas or the biggest unknowns that we have in this area right now?
We know a lot of already factor and theory that explain many factors and social factors that affect human behavior. Something that we need to go deeper, and we need to try to develop a model that actually integrate those factors to make prediction of decision, like prediction of exit choice, prediction of evacuation time, instead of using a completely random distribution. We need to push towards the development of a comprehensive evacuation model that can be implemented in existing evacuation model, and they're actually capable to predict choice in a similar way that you will observe in reality. And this has been the core of my PhD research, and is a long path, because sometimes we don't have enough data, sometimes we don't have data that cover all the possible situation. And so it's a matter of keep gathering data and try to use new technology and new statistical and machine learning approach to go deeper and develop those models.
Yes, I think it's really cool to hear you describe this because it's almost like you're building right from the granular details, right from the level of the inputs going into the model, but then you have to consider the effects this has on a full scale, right? From just the input data to how the model functions to even what this means for how this model can be used or what advantages it might have over existing technologies. So I think it's really interesting to hear about how far this field has progressed in terms of all of these technological aspects, but then even more so about how much room there still is to improve and how we can't even entirely imagine what the accessibility of new tools will be, just say 10 years down the line. And finally, if someone's curious to hear more about your work, where might they go?
They can just type my name and surname on Google Scholar, and find all my papers, or otherwise it's my website is my surname lovreglio.info.
All right. Well, I'm sure if anyone's more interested, they can contact you there. And thank you for taking the time today.
Thank you.